My name is Brett Robblee. It is March 2023, and I teach C++ for business applications at Cal State University in Fullerton, California. I am teaching through Murach's C++ Programming, 2nd edition, and this is part 2 of a lecture on Chapter 6, How to Work with Data Types, Strings, and Vectors. Today's lecture focuses on the string type. Let's get started. The textbook authors capture several important aspects of working with the standard string type in the Create Account program on pages 230 through 233. I typed the code into my IDE. I'll build and run it to demonstrate the console inputs and outputs, and then I'll walk you through key areas of the program. So I just dragged the console across. I put in a tab character and some spaces, and then I typed my name. Now I'm entering a password and demonstrating some of the checks that it is making against the string that is storing the password. Now I put in 8 special characters and it wanted at least one number character, so I'll put in a number character. Okay, and it accepts that as our password. Obviously, you could add to this program and put in more checks, but this is enough for our purposes now. First, note on line 2 that we include the string header, and so that pulls in the string type functionality to our program. And then down here on line 11, we are declaring full name as a type string and first name as type string. Line 13, we're creating a Boolean variable that will help to control the while loop, which is the main loop for getting input on this program. So line 16, we display a prompt. Line 17, we take input from the user. And I put in a tab and I put in some spaces, and then I typed my name. And that's so we could demonstrate in line 20, stripping white space from the front of any input. So if it comes in a file and it has spaces or tabs in front, you can ignore those or skip over them. So full name, being of type string, has methods. It's an object underneath the covers. And this particular method says find first, not of. And then there are 3 characters that it's looking for. It's going to find the first character that's not a space, that's not a new line, and that's not a tab. So those are the 3 white space characters, as we call them. And this code is finding the offset into that string that was returned from the console and storing the first non-white space character index into that string as an integer I. Now, if this member function or method didn't find a blank space, a new line, or tab character, then it would return -1 in I. And so we're testing if I is greater than -1, then it must have returned something, an offset 0 if the first character was a non-white space, or maybe I is 20 because it was the 21st character into this long line of input. That was the first non-white space character. Then full name is equal to full name dot substring. So here's another method that's attached to the string type. And basically it returns a new string object in place of the first one. And we're telling it, hey, start at I, start at the offset, which is the first non-white space character. And so a new string is returned, and it just basically strips off anything before. Then we get the first name by using full name, which now has what I typed on the console, Brett space Robblee. And so using find, which is another method attached to the string class, we're looking for the first space. And so it returns the index to the first space if there is one. And then we use that space index. So let's say BRETT, the first space would happen at the 6th offset, which is 5. So space index has a 5 in it. And then we say first name starts at the 0th offset and goes for 5 characters. And so that's how Brett ends up in the first name. And then we say valid name is true. Now, had line 26 returned a -1, that means it wouldn't have found a space and it wouldn't know if this was a first name or a last name or just general nonsense. And had it not found a space, then it will say to the screen, you must enter your full name. Please try again. And then it loops around and it tries again. Now, moving on to line 37, this is where the password routine is. We now create a string on line 38 called password. And again, we set a Boolean flag that will control the while loop. And now we assume the password is true, that it's a valid password. That's just our expectation. Now we're going to go through and we will ask for the user to enter the password, and then we'll start doing various checks. And if the check doesn't pass, then we'll invalidate the password flag, and then we can loop around and try and get it right. So you can see here in line 50 that password, being of string type, also has a method called length. And so we're able to test the length. And so this is an easy check to allow us to enforce a password length of at least 8 characters. So here, if it's not 8 characters, we say so, we invalidate the password flag, and we move on, and we're checking for numbers. So find first of, where we give it a set of digits in this case. And so we're checking to make sure that it includes one of those 10 digits. And if it doesn't, returns a -1 and it complains. We invalidate the password flag and we loop around again eventually. Make sure the password includes a special character. So now we set up a Boolean for special character, and we use a new for loop that I haven't shown you. And this for loop says, set up a character called C and loop over password because it's a string, and then check each character to make sure that it's a punctuation. Okay. If it's a punctuation character, then we set special character equal true and we break out of the loop. So we're not looking at every character. We want to find at least one punctuation character. And so that's a new type of a loop. Now we check this special character Boolean. If not special character, then we display that on the screen and we invalidate the valid password flag again. And then you can kind of follow that logic. Now, there's different techniques here, but that's because the authors are trying to show you various ways to do similar things or the same thing. At the very end, line 89, make sure the first name uses initial capital letter and then a lowercase. And so they're demonstrating here that even though a first name is a string class, we're able to use an index or an offset into that to get a single character. And so letter is a char variable. We copy the first character from first name string into letter, and then we overwrite the first name first letter, which is at the 0th offset, by calling the toUpper function from the standard library. And that takes letter, and if it's a capital B for my first name, then toUpper has no effect, but it returns a capital B. If I had typed in a lowercase b, then toUpper would convert it to an uppercase B and again return the uppercase B, which overwrites the first letter. So we're going to write into that first position no matter what, but it's always going to be uppercase B thanks to this toUpper function. Then we loop through the first name, which is that string, and we use the length method to make sure that our loop doesn't go too far. And we look at each character, and we store each character in first name after the first, and we force it to lowercase. Just in case I had the caps lock on and I typed, lowercase b and then uppercase RETT for my name, this would fix that problem. And that's a demonstration of how that works.